Hey everybody, how's it going? Here to bring you another VESTA tutorial, but this time we're going to be making a heterostructure of two monolayers. We're going to be making tungsten selenide and molybdenum sulfide monolayer. So let's go ahead and open those structures. I have the hexagonal unit cells of both of them. I'm going to be making a couple videos sort of back to back. So if you have not subscribed to my channel, please subscribe. I usually release videos in bundles, sort of like make a few, set them on a timer, release them. And so there's a new bundle coming, and you should get the videos first. So, please subscribe to the channel and please leave a comment if you like the videos. Just say, hey, great video, whatever. If you don't like the video or you have a comment, please leave it below if you have a question. So anyways, we're going to make this monolayer. There's our heterostructure monolayer heterostructure, however you want to say it. Basically, there's a couple ways to make it, and I'll show you how you can do that. There's a couple different orientations. One thing you might notice is if I just load the structures individually, here's basically what I get. But let me load them together, like how would I load these in just one file? So what I would do is I'd go to open. So let's just open one of them, molybdenum. Let me actually delete these to be a little more fresh. So let's go ahead and open them up. So here we open up molybdenum sulfide. And now you notice before when I opened up tungsten, it opened up a new tab in VESTA. But let's say I want to just have it be in the same tab. How would I go ahead and do that? So what you do is you would not go to open like this. You'd actually go to edit data, phase. And you can see this is the name that's in the top of the VASP file. I'll show you that in a little bit. Then you go to import. Okay. And since we have the molybdenum sulfide, we're going to go ahead and do the tungsten selenide right there. So this W2SE4, this is here in the top of your VASP file. This is up here. Okay. So we'll go ahead and press apply, and you can see that now they're both in the same structure. And you can see that the unit cell is a little different. And here's what we're going to do for this. So what we're going to do is we're going to go ahead and delete this, press apply, and we're going to go and save this as a VASP. So we'll do molybdenum sulfide tungsten selenide monolayer heterostructure .vasp. So we save this as a VASP, press save, Cartesian coordinates. Okay, now come over here to your text editor and come into here. This should have the everything for just the molybdenum sulfide. So first thing I'm going to do is rename the file, how we had it, molybdenum sulfide, tungsten selenide, monolayer hetero. And this is for the molybdenum sulfide. What we're going to do is actually do this for the molybdenum selenide, or the tungsten selenide as well. So let's go ahead and copy this. Just keep this here actually. We're going to go to the tungsten, and we are going to copy this. And we're actually going to place it right below here. And all we have to do is take averages of these. This is probably a good way to get the combined unit cell. It's a standard way. Of course, you should definitely consult the science literature, the material science literature to double check this. So we're going to take these first values and we're going to plug them into our calculator. So load up the calculator. So this, plus this. We'll do this for each one. It's a little tedious, but, and then divide it by 2. Okay. So boom, there's our first one. Let's go ahead and do this angle. So this plus this equals divided by 2. All right, there it is. There's our quote unquote, angle. This one, let's go ahead and try to do this, plus this one divided by 2. Okay, that's there. And then this is the last one here. plus this one equals that divided by 2. Beautiful. Okay, that one will go here. Now what we do is we just copy the zeros, and this is actually really easy to do in the FAR3 viewer like I'm doing here. And then these are just zeros down here. Oops. I meant to press Alt. And okay. Oops. Okay, so just make these zeros and make this the 14. Okay, so this is actually of the combined unit cell, so we can go ahead and delete these. Now I'm going to save with F2, exit, reopen. So we have our new unit cell up here. We don't know these coordinates yet, but we will have molybdenum and sulfide. We will have tungsten and selenium. Okay, so let's go ahead and just save this for now. Okay, so actually I'll go ahead and delete these and delete these. Save it, exit. Okay, now let's go back to our structure here, and we're gonna go to edit data unit cell, and we're gonna go to phase, and we're gonna import the tungsten selenide. Press apply. Okay, perfect. Now what we need to do is basically just delete one of each, right? So press apply. Okay, so now we have it like this, and we are going to go to edit data structure parameters, and now you can see the two phases up here. So let's go to our molybdenum sulfide, and we can see this sort of C dimension. Now what we're going to do is delete the molybdenum sulfide on the bottom. So basically anything with a low C value. Let's get the C value here. So this is 0.3. So anything 0.3 and below, we're going to delete. So delete this. Oh, sorry. Let's do something first. Actually, 2 molybdenum. Oh yeah, no, we're good with this. Sorry. So let's go ahead and do. Let's actually go ahead and do edit bonds. Open this up. Delete that, and then we'll go to tungsten selenide and delete these. Press apply. Yeah, this is what I wanted. This makes it way easier. So you can just press OK. You can actually get out of here now. Just press a. Oops, sorry. All right, go back to bonds and go to delete, apply, and then go to delete, apply. Excuse me, everybody. It's a allergy season. Press OK. Okay, this is actually what I wanted before. So now we just delete one of the atom types. So we're going to make them as closer. So we'll go ahead and delete this and delete this. And that is basically it. So now what we do is we have to save as an XYZ. So we go to File, Export Data. We're going to click on this, get rid of the .vasp, and go to XYZ. Save. Save in MEMS? No. Let's go to our text editor, and then we're going to click into here. And now you can see you have our MoS2 WSe2. We're going to paste this into here. So now we have to do, the first atom is molybdenum, the next 2 are sulfur, then we have 1 tungsten and 2 selenium. So these reflect this order, and we're going to delete these, press F2, save, and now we're going to look for this tag up here. Let's go back to VESTA. Open this up. Okay, there we go. Something. Oh, I see the error I did. So let's come back to here. That's my bad. It's the gray with the green and the purple with the yellow, right? So what we need to do is get rid of the purple. Get rid of the purple. Well, why am I doing? Why is it doing that? Get rid of the purple and the yellow. And down here, get rid of the gray and the green. That's called checking your answer. Okay, now we go to File, Export Data. The same thing. Click here, save, replace it. Do not save hidden atom. Come back here, recopy these. I think you guys and girls get the hang of this now. Okay. Save this. Now let's reopen. This will be much better now. There we go. There we go. So this is how you make the heterostructure with them basically right on top of each other. They maybe should be closer, but it's probably fine for now. So let's go to bonds and we're going to delete everything. Okay. And then let's expand this. Let's do 6 by 6, press apply. Yep, so this is basically the structures with them pretty far away, and this is the modified unit cell that we made. Space filling, this is the money shot for like a publication. Yeah, this would be them right on top of each other, but what if you wanted to have it so the molybdenum was like in the middle here, you know? There's a couple ways you could do that. You would basically need to move one of them to the corner of the unit cell. So what we could do, I'm just going to press Control Z to go back to here. So we have to move one of them to this corner. So we have to shift everything by a constant. And you can see here, if I press A, you can get a good measure of what the unit cell coordinates are. So let us go ahead and shift. I actually would need to visualize this again. Yeah, so we're going to shift the molybdenum atom and the sulfur atoms basically by a constant in B and A. So let's go to view or edit data structure parameters. Okay. So now I basically got to figure out what is this value here. And that value would be, actually, you know what, we can go ahead and do it here. So it'd be 0, 0, 0 for the molybdenum. Let's try this out. Let's try 0, 0, 0. So yeah, move the molybdenum to there. I'm going to undo that. Press cancel. Okay, so that's not exactly what I wanted. By the way, this is me working in like real time. So we actually I like this distance in the C dimension. So we're going to keep that, and we're going to just move A and B to 0. So 0, 0. Press apply. So you can see it moved it there. And then we're going to move the A and B of the sulfur. So 0, 0. And this is 0, 0. Press apply. So it's like this now. Something's still not right. I think I messed. Oh yeah, I didn't move this one to 0. There we go. Press apply. Okay, so that's still not right. I think I missed a crucial point. Let's go back. Let's see where we were here. And okay, so I moved the molybdenum how much to the left? That's what I forgot to track. So let's cancel this. Go back to edit data structure parameters. And we do, so we're going to move this 0.652. So I'm going to go ahead, open up my notebook or my calculator, and I'm just going to paste this value here. I'm actually going to write it down quick. 0.652879, and this next one is 0.326439. Okay, yeah, just so I know when I make this a 0, that's what I took away, 0, that's what I took away. Press apply. Okay, now to this one, I think this one will become minus, and this will just become this, and then this will be the same thing. So this will become minus here, and this will just become that. And then press apply. This one was never put back, so let's go ahead and do that. Press apply. There we go. Press OK. Now let's go ahead and expand it. And you can see that the molybdenum now, let's make it 6 by 6. Press OK. the molybdenum now is sitting in between. This is basically another way that you could do the monolayer. Oops. So we'll go ahead and I'll delete these as well. So let's go ahead and look from C. Yeah, so you can see basically that this is a different orientation. This is not them directly on top of each other, but rather sort of shifted a little bit. And this would be very important for like studying the different surface energies, basically the different combinations. So here the molybdenums sit in between. And in the other one that we had before, if I open that up again, and then I do space filling, properties, sorry, not properties, boundaries, let's do 6 by 6. Okay, here you can see when you look through, everything is directly on top of each other, right? So let's go ahead and make this B, and then we'll shift. Everything is directly on top, right? We'll go ahead and take a snippet of this. Actually, I want to move this like this. We'll take a snippet. Okay. Now, when we go to here, let's make this B. You can see the things are not exactly on top of each other. It's shifted a little bit. And this is a different type of system, basically. It's not going to have the same energy. And I think there's a paper actually that shows this exact thing. If you look at this through the C dimension, maybe I'll flip it. You can see that the tungsten are sitting basically in between these little squares here. It's a different packing orientation. Whereas here, there's nothing but white space between them. And so yeah, these are the two layers. If you want to bring the molybdenum layer closer to this layer, you go to Edit Data, Structure Parameters, and you would just basically shift everything up. Let's make this shift everything up by 0.1. So this becomes 3. This becomes 4. This becomes a 2. So you press apply. Oops, I guess I don't know what just happened. Maybe it's not that straightforward because maybe it has to do with the, or maybe this one's supposed to be 4 and it didn't go. Yeah, I don't know. So, something messed up. Press cancel and then just Control Z it back. Yeah, but basically you would just shift everything up by some constant. Maybe I could do it in the file here. So I have my molybdenum sulfide. Make this, this would be let's make it 2.5. This would be 5.1, 1.9. Save it. Come back here. And you can see it's just basically shifted in that dimension. So then we go ahead and let's undo that now. So everything back by 0.2. This would go to 3. This would go to 4.9. And this one would be 1.7. Save. Let's open it up. Space filling A. Space filling A. Yes, and you can see when I click back and forth now between these that it's a big difference. So what I'm going to actually do is I'm going to save this one as a new VASP. So File, Export Data, and I'll call this hetero shifted .vasp, and let's save it. Okay, so let's open it and see what we have. Yes, and you can see it's a much different crystal now that you have these sort of in between. So when I go ahead and expand this, 6x6 it, space fill. Yeah, you can see it's very different now, and it's actually pretty cool that you can do this. So what we'll do is we'll come into our text editor, and we're going to move everything by 1. This will be 4, 5, 2. Save it. Okay, we'll make this A. And then let's open up a new one. A. You can see they're much closer now. Let's do space filling. Okay, we can do some more. So let's go back and do some more. We'll make this 3, 6, 5. So we did everything by 2 angstroms in the C dimension. Open it up. Okay, yeah. So you can see it's much different now. Space filling, these are the electron clouds basically, and they're pretty close to each other. And so now let's go ahead and expand this 6x6. Yeah, this is the money shot right here. So this is one situation. I'm going to go back to the original one, and I'm going to make this 3, 6, 5. Let's save it. I'm going to exit out of these ones. No, 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 nope. And let's load it. Let's load that up. That's pretty interesting. Yeah, you can see these are basically right on top of each other. And let us do both cases where we do edit. Let's get rid of the bonds. Okay. Then we'll come here. We'll do edit bonds, get rid of them. Press apply. So I'm just moving pretty fast to try to get you guys the information you need. Okay, so here we go. We're going to press A here. A here. So here's the difference between the two, if you can see. The difference is that one of them is basically shifted. So see how these ones are lining up? These ones have been shifted down here. If we look at C, you can see in between. There's the molybdenum in between. And here, if you look at C, they're right on top of each other. So yeah, that's the difference between the two. Hope you guys learned a lot. This is a molybdenum sulfide tungsten selenide monolayer heterostructure. Made a lot of mistakes in this video, but that's how it really goes. It's not like my other videos where I kind of have some experience. I've never done this one before. This is live video, so to speak. But yeah, so if you have any questions, leave them down below. If you have not subscribed yet, please subscribe, and I'll see you next time.